Welcome to the Explainer. So today we're actually looking at a blueprint to literally engineer our way out of a massive global crisis. We're talking about green engineering. And, shifting how we build things isn't just some nice-to-have bonus feature anymore. It's absolutely a planetary necessity. If you're wondering how we can actually fix the huge environmental problems all around us using structured, applied science, well, you are definitely in the right place. Let's get into it.
Okay, really quick, here's our roadmap for this explainer. We'll start with a silent global crisis, then look at rethinking education and business, contrast traditional versus green engineering, dive into a hyperlocal paint manufacturing case study, talk about redesigning for sustainability, and finally check out the future of green jobs.
Section 1, the silent global crisis, the true cost of air pollution. So let's dive right in by confronting the massive, almost unbelievable scale of this crisis, using some incredible insights from environmental expert Dr. Wissam.
7 to 9 million, right? According to the World Health Organization, that is the number of people who lose their lives every single year from air pollution. Just to put that into perspective for a second, Dr. Wissam compares this to COVID-19. Over a few years, the pandemic claimed around 7 million lives, and the entire world rightfully ground to a halt. Yet, we are literally losing that exact same number of people to air pollution every single year, and it barely even makes the front page.
And that brings us to a really terrifying psychological reality: data fatigue. Dr. Wes Simone brilliantly points out that imagine if you woke up and heard 20 planes crash today and then 20 more tomorrow. It would be a shocking global emergency. But because these millions of deaths from air pollution happen silently, through respiratory distress, heart disease, slow environmental degradation, we just really struggle to comprehend the emotional weight of those numbers.
And look, if the sheer humanitarian tragedy doesn't move the needle for some decision makers, the economic one absolutely will. We aren't talking millions here. We are talking trillions of dollars lost globally every single year. Pollution forces governments to spend massive amounts on medical treatments. It reduces agricultural crop yields, which straight up threatens national food security. And we've all seen how just one regional conflict or environmental disaster can completely disrupt global supply chains. It just proves that local pollution very quickly mutates into a massive global economic crisis.
Moving on to Section 2, rethinking education and business, shifting the paradigm. We obviously can't keep building the way we always have. So, how do we actually begin to solve a crisis of this magnitude? Well, here's a really surprising fact. For decades, businesses basically viewed environmental compliance as this giant drain on their wallets, just some annoying regulatory hoop they had to jump through. But the paradigm has completely flipped. Treating the environment as an afterthought creates massive external risks. It turns out, early adopters who treat environmental strategy as risk mitigation are seeing up to 20% higher profits compared to traditional businesses. So actually, scratch the old way of thinking. Doing the right thing is incredibly good for the bottom line. But to actually capture those massive profits, we need the right minds on the job. Dr. Wissam argues that we can't wait to retrain people years after they graduate. We need holistic education. That means whether you're studying to be an accountant, a social scientist, or an engineer, sustainability needs to be your native language from day one. It creates this common framework among professionals so everyone is ready to implement clean practices the absolute second they hit the workforce. Section 3, traditional versus green engineering, a new way to build. Let's take a look at what this transformation looks like on the ground, specifically within the engineering sector. So traditional engineering kind of had tunnel vision, right? The questions were just, does the bridge stand up and is it cheap? Green engineering completely shatters that silo with something called life cycle assessments. This means zooming way out. You aren't just looking at the finished building anymore. You're tracking the carbon footprint of the bulldozer digging the dirt, all the way to how that building is going to be dismantled 50 years down the line. It's about asking the really hard questions at every single phase. Where exactly did we dig up these materials? How much gas did the trucks burn to get them to the site? What toxic sludge are we making? And, taking it a step further, beyond just doing less bad, how can this project actually heal the local ecosystem? It's really about safeguarding communities from the very first brick laid to the final day of operation.
Section 4, case study, paint manufacturing, from theory to practice. Now let's ground all this high-level theory with an actual student assignment from a green engineering course. Specifically, we're looking at Group 7's analysis of a solvent-based paint facility.
Okay, so think about this chain reaction of environmental risks.
In a standard paint factory, just mixing pigments in open tanks releases massive amounts of volatile organic compounds, or VOCs, which are essentially toxic invisible gases. Then, storing those solvents creates evaporation and ground-level ozone. Filling the containers creates extreme fire hazards, and cleaning the equipment. That generates toxic sludge that pollutes our water systems. Literally, every single step is a major hazard.
Now, the students identified a pretty fatal flaw here. The factory was using what's called an end-of-pipe approach. That literally means waiting until the toxic sludge comes out the end of the pipe, and then paying an absolute fortune to safely dispose of it. The green approach flips this entirely on its head. It focuses on prevention-based strategies and inherent safety to prevent the pollution from ever being created in the first place.
Section 5. Redesigning for Sustainability, the Group 7 Proposal. So, how did the engineering students actually fix this messy, toxic process?
They build a brilliant, super effective 3-step redesign roadmap. Step 1, seal those open mixing tanks into closed systems so that toxic gases can't escape into the air. Step 2, install a solvent recovery unit so you can distill and actually reuse your cleaning fluids instead of just dumping them. And Step 3, substitute the materials entirely. Switch to water-based or low VOC coatings right at the source.
In the benefits here, it's a total win-win. Environmentally, you slash your emissions and your toxic waste. Economically, you stop wasting money buying new raw materials and paying exorbitant disposal fees. But most importantly, on a purely human level, you are protecting the factory workers from daily exposure to explosive hazards and long-term respiratory damage. It just makes sense, right?
Section 6. The Future of Green Jobs, a Massive Market Opportunity. We've seen how this works inside one specific factory. Now let's zoom back out and talk about what this means for your future.
There is a staggering gap in the global market right now. The demand for green jobs sits at roughly 20%, while the supply of skilled green labor is struggling at just 6%. That is an unprecedented, booming job market that is essentially begging for graduates who understand applied sustainability.
And honestly, the best part, you don't have to wait until graduation to bridge that gap. Initiatives like Dr. Waysam's Global Ambassadors of Sustainability span over 130 countries and offer virtual training modules completely for free. It's an incredible chance to build your green skill set and a global network today, no matter where you live or what your funding situation looks like.
We've seen the devastating human cost of ignoring the environment and the multi-trillion-dollar opportunity waiting for us if we fix it. The tools are free, the job market is wide open, and the planetary need has literally never been greater. The blueprint is right in front of us. The only question is, will you be the one to pick it up and build the future? Thanks for hanging out with me for this explainer. Stay curious, and I'll catch you on the next one.